still Lie derivative and killing vectors. Let's continue. Lecture 4, construct chart UX for the manifold M3. Okay, we already did this study before, okay, but I would like just to emphasize the reason I'm repeating here because now we will derive over here with the focus is exactly the Lie derivative, okay, and the killing vector. The application, okay, will be towards the Lie derivative. Now, there's a manifold. For this particular case, M3, okay, this is the real T here belongs to the real space. Now, step 1, define the manifold. M3 is a three-dimensional, this manifold, and gamma, capital gamma, is a smooth curve, such that this is a phi between minus epsilon and plus epsilon, okay, maps to the manifold M3, points on the manifold. Now, by definition, phi of 0 is a point P, belongs to M3, and phi of eta is Q. For small eta, meaning Q is a point quite close, very close to point P. Also, both belongs to the chart U, this here. So I'll repeat this figure on the side. That's the chart. That's manifold. Attention now. Point O is here outside, but point O belongs to the same point P over here, okay? I just work on this side over here, knowing that O belongs to the point P. So this is what we called previously as a fantasy, okay? Which this is a Euclidean R3 over here. Now, the point P, it is obtained exactly from here, okay? Which I apply phi of 0, that's a point P. There's a point P over there. Now we have a map, okay? That the point P, the coordinates of point P, maps to this space, Euclidean space R3. And this is the inverse, okay? So I have many points here, see, over here around this point P, PU, okay? Then this case, I'll apply the backward with this inverse, okay? That's why we construct the chart U, okay? As I mentioned this before, okay, on the manifolds. Now I repeat here, this is the U, the chart U, and this X. This is phi of 0, that's point P. This is phi of eta, this is eta here, okay? That's, again, P and Q, they stay quite close, okay? Because eta over here is just a small increment. That eta belongs to the real space. Now again, X of P is 0, 0, 0 in R3. They belongs, attention now, to the Euclidean space. Likewise, X of Q is eta 1, eta 2, and eta 3, which I call, that's to simplify the notation, I call as eta. Now, attention here, key emphasis. Points P and Q are points in the manifold, not vectors. In this case, in a tangent space. Okay? The chart U just assigns this label in R3. Tangent space TPM3 and TQM3 consisting of tangent vectors at P and Q. That's the most important observation here. These are not, I will put here, these are not subset of manifold. Each is, in this case, is a separate vector space attached to a point. That's important here because this is a point on a manifold. And there's a point of manifold that belongs to the chart U. So TP is just over here. This is a tangent space. Tangent space at P. Okay? And here I can draw a tangent space at Q. That's important. Points in the tangent space, the only point, the point that belongs to the tangent space and U is points P and Q. Attention that, see? So P and Q belongs to the chart, both, see? Not the tangent vector space. Okay, tangent vector space is another collection of points over here, and this here is another collection of points. Okay, but here is a point P, and this is a point Q. That these points belong to the chart U, not these points over here. Okay, they belong respectively to the tangent space. That's a key emphasis I would like for you to understand and keep this in mind always. Now, the basis of the tangent vector space TPM3 and TQM3 are partial derivative with respect to x1, x2, and x3 at the point P. So this is this case is a vector space. Okay, but this also, you have the correspondence that's important here. This case, you have, this is a P M3. So this is a cotangent space. Likewise, for the point Q, you see, this is Q over here. Likewise, for the point Q, it's the same. There's another basis. And this one here is T, Q, in this case, or M3. So this is associated with the vector space. The tangent vector space is associated with the cotangent vector space. Likewise, this one. We mentioned this before, you see? So the tangent vector at point P and Q, xp, is the ordinary derivative of phi respect to t at t is equal 0 that belongs, attention, this tangent vector here belongs to the manifold at the point P, which belongs to the chart U. Xq is the ordinary derivative of phi respect to t. Attention, t is equal eta, a small increment, which lives on the tangent vector space TQM3. That's important. Now xp, now we also did this, okay, in previous lectures, okay. This derivative here, okay, xp, I can use a functions and take direction derivative just to leads to this relation and to that relation. That's important here. This we did this before. Okay. Now I'm recording this lecture just to emphasize just what's written over here. Again, points on the tangent space, obviously they belong to the tangent space, tangent vector space. The points in the chart, the only points on the tangent vector space, okay, that belong to both are point P and Q. Okay, this is another set of points over here. That's why I feel that it's good just to re-emphasize what I did before. Okay, that's an important point.